last meeting, we discussed up to this number 8. There. So today we'll just continue with our problem solving portion. Okay. So once again, this is resultant of concurrent forces as well as components of a force. So moving on to number 9. The block shown in the figure is acted upon by its weight, 200 pounds, a horizontal force, 600 pounds, and the pressure P exerted by the inclined plane. The resultant R of these forces is up and parallel to the incline, thereby sliding the block up it. Determine P and R. So again, our goal is to determine P and R. So I've written down the solution already. Let's just talk about it. So we're looking for P and R. P is this force right here, R is your resultant. According to this problem, the resultant R is up and parallel to the incline. Okay, so this is your R. I drew it this way, up and parallel to the incline. So before I move on to creating my equations, I need to fix this first, okay? So the only thing that was given here was this is P, and it is hitting this point at an angle of 15 degrees. Okay, so in order to use my equations, I need an angle either from the X and Y axis, right? Or parallel and perpendicular to the slope as shown in our previous examples. So to do that, let's first see, remember, perpendicular angles have the same angle between them. So let's look for perpendicular angles. So looking here, okay, this line, perpendicular to this line, right? And then this line, normal to your slope, means that it's perpendicular to this line. Therefore, angle between them is equal. Therefore, this is 30. And as you can see, this is also 30. Okay? This is 30. This angle is given as 15. So this total is 45. This is in right angle with this. Therefore, 90 minus 45, this is also 45. Okay, now I have an angle from the x-axis. I can now use my trigonometric functions. So solving for P and R. So P and R not given. So I'm just going to write equation instead. So we know that the x component of my resultant is equal to the summation of the x components of each force. Okay, so Rx equals summation of Fx. And Rx, this is your R, x component of that. If you follow the line of action, it's this. As you can see, it makes an angle of 30 degrees with the horizontal. Therefore, x component of R is just R cosine 30. And so R cosine 30 to the right, therefore positive. Then equals P is to the left, therefore negative, and the x component of P is this, okay, and Px, Py. So P is to the left, negative, then cosine 45. Okay, next, we have this to the right, therefore positive, so positive 600. So I can't do anything with this anymore, so just label that as equation 1. Move on to the next possible equation, which is your Ry. Again, Ry is your summation of forces y. So Ry, looking here, it's this, also equal to this, which is R sine 30. Okay? So R sine 30 equals summation of all forces y. So starting here, Py is upward, therefore positive, and Py is just P sine 45. Next, we have this weight, 200 pound downward, therefore negative, negative 200. So now that's your second equation. Two equations, two unknowns, you can solve for R and P. You can either use your calculator or manually solve this using simultaneous equations. If you do, you'll get 292.82 and 489.90. Once again, I urge you to practice solving this at home so you won't have a problem during your exam on how to get these values. Okay? Again, familiarize yourself with your calculator. All right, that's number 9. Any questions for number 9? Okay. You may answer in the chat or use your mic.
Wala po, ma'am.
Okay, how about the others? Store. I don't know what's your calculator, so you can search on the net, but for me, you're gonna hit shift. Yeah, you can search it on your own. But for me, oh, we're almost the same. So shift, so pick a letter. So let's say A. And that's how you store it. Shift, so A. They're at the upper left and left side of your calculator. And then if you want to retrieve your value at A, just hit alpha. And then A. Okay, so there. So that is your resultant of parallel force systems and component of a force. Next topic is moment of a force. So the moment of a force about an axis or line is the measure of its ability to produce turning or twisting about the axis. So the magnitude of the moment of a force about an axis, which is perpendicular to a plane containing the line of action of the force, is defined as the product of the force and the perpendicular distance from the axis to the line of action of the force. In short, M is product of F and perpendicular distance D. So for example, you have a point O, and then you have a force F. To get the moment of F about point O, it's just F multiplied by this perpendicular distance. Okay, so M equals FD. What if I don't know the perpendicular distance? Then you're going to use Varnam's theorem, which we'll discuss later on. So that D is what we call your moment arm. So the moment arm or lever arm is the perpendicular distance between the line of action of the force and the center of moment. So again, that was your D. The center of moments may be the actual point about which the force causes rotation. So for example, it's the shaft. Okay. Or it may also be a reference point or axis about which the force may be considered as causing rotation. It does not matter as long as a specific point is always taken as the reference point, and then the latter case is much more common situation in structural design problems. So this just means that it's more common that we choose our own moment center. Okay? We're gonna use a convenient point to take our moment on. So later I'll show you how. But once again, what if we don't know that perpendicular distance? You're gonna use Varnam's theorem. So according to Varnam's theorem, the moment of a force is equivalent to the sum of the moment of its components. So we already know how to take component, right? So therefore, you know Fx and Fy. So just take the perpendicular distance of Fx and Fy, which is just the y and x distances respectively from your arbitrary point O. So in equation form, M is just equal to summation of forces and their distances. And this D again is perpendicular distance. If you don't know that, you're going to use its component. So summation of all forces X and their respective distance Y from the point plus summation of forces Y and the respective distance X from the point. Okay. And similar to your components of a force, you also have sign convention here. So clockwise is positive, counterclockwise is negative. In other books and for other professors, it might be the opposite. The choice of sign is arbitrary, meaning has no actual rule to it. It's up to you what's more convenient to you. But for us, for the sake of uniformity, we're going to use clockwise, positive, counterclockwise, negative. Again, you might see in other books it's the opposite. That's just because this is arbitrary. Okay? So let's talk about this equation. So let's say we have a figure like this, right? We have a stick or any horizontal structure. We have a force 1 here, a force 2 here. According to our equation, summation of moment, and you're going to take the moment about a certain point. So let's say I take it about this point A. And summation of moment A equals summation of your forces and their distances. Okay. So summation of moment A equals the summation of each of this. Let's start with F1. Looking at F1, if I extend its line of action, right, I can directly see the distance, perpendicular distance from A, which is 1. And then use your sign convention, clockwise positive, counterclockwise negative. So how do I know that? Rotate your force about your chosen point and choose the shortest path. So for F1, this is upward. If you rotate it about A, it's going to look like this. And that is clockwise motion. Okay? How do I know it's this way? Because if I go this way, that doesn't make sense, right? I change direction. So no, it's this way. Clockwise, therefore positive. So positive F1 times perpendicular distance 1. Next, F2. So for F2, again, try to extend its line of action. And as you can see, imagine this. This is the perpendicular distance from A. And I don't want to solve for that. So instead, what you're going to do is, you're going to get, once again, the components. So to get a component, usually we do it this way, right? But now you can just do it this way as well. Remember our transmissibility. You can draw your components anywhere along the line of action. So I'm going to draw it there. This is now F2y. This is your F2x. And now it's easier to get the perpendicular distance. Let's start with this vertical force. So extending the line of action of F2y, you get this. And this is the perpendicular distance. And as you can see, it's just 2. We have a vertical force. We have a horizontal distance. That's why in the equation earlier, fx dy, distance y. It's because of that. Right? And then check if it's clockwise or counterclockwise. So rotate F2y about 8. So this is counterclockwise. Right? Again, it's not going to be this way because you change direction. So counterclockwise, meaning negative F2y times distance, which is once again 2. Okay, and then lastly, F2x. So rotate F2x about 8 to get the sign. As you can see, that is clockwise. It's not going to be counterclockwise. So positive F2x and extending its line of action. This is its perpendicular distance. And as you can see, that distance is 1. So times 1. Okay? So that's your Varnam's theorem. Right? So now let's put that into practice. Let's have our first problem. In the figure, a force F passing through C causes a clockwise moment of 120 foot-pound about A and a clockwise moment of 70 foot-pound about B. Determine the force and its x-intercept. So you have a drawing there. Most of the concept is already drawn. So instead, let's do it this way. Because most of the time, there's no drawing. Okay, so you have to figure out how to draw it. So let's take it one by one. In the figure, a force F passing through C. So you have this axis, this is your ABCD. We know your force F is going to pass through that. So it's passing through C. That's how I drew it. Next, causes a clockwise moment about clockwise moment of 120 about A. This is your A. So I need to position F in a way that it's going to create a clockwise moment. Okay? So this would either be this way or this way. So you have to check. If we do it this way, rotate it about A, it's going to be this. As you can see, that's counterclockwise. So this is incorrect. Therefore, the correct orientation would be this. Yeah, would be this. And upon checking, rotate it about A, it's clockwise. So correct. So we have given summation of moment about A is 120 foot-pound. Okay. Next, clockwise moment of 70 about B. Again, clockwise, that's positive. We can just write that immediately. Summation of moment at B, 70 foot-pound. Okay. Write that here. Now it's positive. So generally, I don't know actually if it's here Mhm. I don't know if this line is here or here. I just place it this way for now. So to check, it's 70 foot-pound positive. Now what if I drew it this way? Will my force create a clockwise moment about B? So let's check. If my force is outside of B, the direction is this way, right? Rotate this about point B. Rotating about point B, you get counterclockwise. So no, your force will not be outside of B. Therefore, it's inside of B. This is the correct drawing. Okay? So to check, once again, try to rotate this about point B. Okay, once again, your direction is this way. So rotate, and you get a clockwise direction. So positive. Correct. So now that's your drawing. What are we looking for? Determine the force and its x-intercept. So we're looking for F. So let's call this F. And how do we do that? We're gonna use what's given. Let's start with, we're given moment about A. And we already know how to take moment, right? Summation of moment is just force times distance. Okay, so summation of moment about A is just summation of force times distance. So once again, this is 120. Now what is my force? That is what we're looking for in the distance. So remember your transmissibility, meaning you can put your components anywhere along the line of action for F. Now this is where you learn that you can make your solution shorter or make the analysis easier depending on your choice of position of your component. Okay? So your component can either be here, 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 and okay? So now learn how to choose where to put it to make our solution shortest. So then we're taking moment about A. It's this point. Now look, what if I take my component at this point, at C? So if I draw my components, this would be my Fy, this would be my Fx. Okay? Now Fy passes through A. And remember, whenever a force passes through the point wherein you're taking the moment of that force will now be 0. Why? Moment is Fb. In this case, force passes through your point in question. B is 0, so that would be 0. Okay? So in short, I want to place my components in a way that one of them will pass through the point in question so that it will cancel out, or I don't have to write it or include it in my equation anymore. Okay? So let's do that. And that is where I'll put my force. Once again, Fy is 0. Okay? So 0 for Fy. And then Fx, determine clockwise or counterclockwise. So rotate Fx about A. It's clockwise, therefore positive. And then Fx times 2. Okay. Fx is easily solved for. That's just 60. So 60 pounds. I have Fx. Now, if I can just get Fy, I can solve for F using F equals square root of Fx squared plus Fy squared, remembering your components of a force. So next goal is to get Fy. How? Look at your other given. I'm also given this. So if I use what I did earlier, but instead equating it to MB, I could solve for Fy. So let's try. Once again, you can choose where to put your component. Okay. Let's say I got lazy. I just want to put it there. That's fine as well. So taking your component there, once again, summation of MB is just summation of FB. So MB 70 positive. So let's start with Fy. So Fy now has a distance from point B, so that's not 0 anymore. So rotate it about B. As you can see, that's clockwise. So positive Fy multiplied by perpendicular distance from B. If you extend the line of action of Fy, perpendicular distance is just this, which is 5. So that's 5. Next, Fx. So Fx, rotate Fx about B. So as you can see, that's counterclockwise. Okay. So minus Fx. How do I know? Well, if I rotate it this way, yeah, it's taking a longer route than just doing it this way. Okay. this just goes straight down. This goes up, then goes down. So take the shortest path. So that's why I know it's counterclockwise. So minus fx times perpendicular distance. Once again, you can extend the line of action of fx. This is the perpendicular distance. And that distance is equal to this distance, which is 3, multiplied by 3. Okay. I already know to be 60, therefore I can solve for fy. What's the value of fy? Correct, Angela and Erwin. So the Guzman and about Garing and about, oh no, it's not 65, it's 50. So who was that? Christelle. Okay, so Garing and Lakian. Garing. So JKL. Okay, it's 50. Sorry, Erwin. So 50 pounds. Once again, my goal is to get F. So to get F, that's just square root of fx squared plus fy squared. What's the answer? Correct, John Relor. They are the only one who solved. So just you, Relor. 78.10, correct. So that's the first part. Now we're not done. Okay. Whenever you're looking for a resultant or a force, a total force, and there's usually something beside that, so it's x-intercept. So we're looking for x-intercept. What is that? X-intercept is just the point where it crosses your x-axis. So once again, extending this, it's this point. We're looking for that point, and let's just call that point ix, distance from center of axis to here. Okay, so we're looking for ix. Meaning, to solve for that, I need an equation involving ix. Right? To do that, one technique that we can do is to reposition my components. So, yeah. So instead of there, if I put my components here, to get a summation or moment about a certain point, I'm gonna need ix. How? If I take the moment about B, so distance of fy about B, I'm gonna need this distance, right? Which is just 5 minus ix. Okay, so that's how. So let's create an equation out of that. So once again, let's take summation of moment about B, and that's equal to 70, which is equal to summation of forces B. So 70 equals, again, considering this, let's start with Fy. Fy is clockwise about B, so positive Fy. Then perpendicular distance. So the perpendicular distance is this, which is again just 5 minus Ix. There. Next, f of x. F of x is this way rotated about B. You can't because it actually passes through B, so that's 0. Okay. And we know Fy is 50. So now you can solve for Ix, which is what? What's Ix? Correct, John and Angela. So Garing and Pamitan. 3.6. Then don't forget the unit. What's the unit? Yeah. So this means feet. So feet. Then to make it more specific, you can say 3.6 feet. I don't know. That's enough for intercepts. Okay. So, by the way, that's not done. In order to get a complete answer for force, we also need to get the angle. So the angle would be this, or from the x-axis. So what if the problem has an additional question? Get the angle of your force. Okay. So usually when you get the angle, that means angle from the x-axis. Okay. So to get that, we're gonna use one of your equations for components of a force, if you remember, which is theta equals arctangent Fy over Fx. Okay. Fy is 50, Fx is 60. What's the answer to theta? Correct, Jermaine and Kathleen. So do and Warbe. So Kathleen and Warbe. Who's that? Dupra. Okay. So 39.81 degrees. And then direction is upwards to the left. Just up to the left. Okay. So whenever looking for resultant R, the complete answer would be this, or force F rather. Complete answer would be magnitude and direction. So there any questions with number 1? But the others, number 1. Okay, great. Let's move on to the next, number 2. Number 2. It's a bit long. In the figure, compute the moment of force F and force P about points A, B, C, D. So it's pretty straightforward. F is 200, P is 165. Actually, let's just write that here. kg? Was it kg? Yep. And then 165. So what are we looking for? Moment about ABCD. That means moment of each forces about ABCD. So remember to take the moment, that's just force times distance, perpendicular distance. So from A, this is the perpendicular distance. From C, this is the perpendicular distance, and so on and so forth. I don't want to solve for that, so instead I'm going to use components. Okay? So meaning I'm going to be using Fx and Fy. So I need to solve for Fx and Fy. Okay. Now you can do that within your equation for moment, or you can do it first as a preliminary solution so that your solution is easier. So let's do the second one, the latter. So let's solve for Fx and Fy. So we're not given angles, we're given matrix or a graph, which means you can get the slope of your forces. Okay, so to get the slope of this, let's choose a different, a brighter color. And count the number of blocks long and blocks high your force is. This is your force. It's 1, 2, 3, 4 blocks as a base and 3 blocks high. 3. 3. Okay, so for 3, So hypotenuse is just 5. Yes, it's 3, 4, 5. No need to solve for that. Next, do the same thing for P. Okay. So it's 2 blocks as a base. It's 3 blocks high. And then therefore that is square root of 13. Okay, we already know how to take R, right? Just square root of 3 squared plus 2 squared, that's square root of 13. Now what if my drawing is this way? It's very long. Doesn't matter, just count the full blocks it has. So I already know this is 2 full blocks, this is 3 full blocks. Okay? Here, I don't know how many blocks high that is because of this. Okay, so I'm not gonna use this length. Okay, choose points wherein it intersects your graph, which is this and this. Okay, so those are your slopes. So now I can solve for this. So fx is just 200. I'm gonna give you the answer here to make things faster. So that's just 200 times fx. To get fx, get the side that is parallel to x, which is 4. Then over hypotenuse 5. 200 times 4 over 5 is just 160. Fy is just 200, then y vertical is 3 times 3 over 5. 200 times 3 over 5, that's 120. Now solve this with me, px and py, because these aren't whole numbers. Px is 165 times x. Horizontal component is this, so times 2 over square root of 13. 165 times 2 over square root of 13, that's 91.53. Once again, compute for this and then store this in your calculator to make things easier later. And then lastly, do the same thing for py. That's 165 times y. That's 3 over square root of 13. And the answer to that is 137.29. Yes, correct. 0.29. And once again, store this in your calculator. Okay, now we can get to actual solving. So let's start with F first, since the goal is to get moment of each force about A, B, C, D. So let's start with F. And then let's start with A to B. So summation of moment about A. Okay, so let's start Fy. Let's start with Fy. Now, again, the next step is to figure out or to choose your position of your component. And usually you do that in a way that it's the most convenient, wherein one component cancels out. I'm taking moment about A. So in order for one of my components to cancel out, I can take my components here, right? It's the same thing. Again, you can get it here, 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 so on and so forth. Just choose the most convenient position. Ito na lang. Yan. I'll take it here. By the way, make sure your direction of components are in line with the actual direction of your force, right? This is to the left, to the right and upward. So components should also be to the right and upward. And as you can see, fx passes through A, so that cancels out. I don't need to use that anymore. So I'm just going to use fy. Now fy, rotate it about A. That is counterclockwise. So negative fy times distance. Each block is 0.3 each side. So this is 0.3, 0.3, 0.3, 0.3, 0.3. So that's just 1, 2, 3, 4, 5. 5 blocks times 0.3. Or 0.3 times 5 blocks. Okay? And I already know fy is 120. So 120 times 0.3 times 5, that is what? Negative. Correct, negative 180. Is that Castillo and De La Vega. Andre and Kathleen. Negative 180. Our unit is in kilogram. And then this is moment. Oh, what did I write for moment here? This is moment. So unit of moment is actually force, the unit of force times the unit of measurement for distance. This is kilograms. Our unit of measurement is meters. So the unit here is kilogram meter. Okay. And then summation of moment at B. Let's look, where's B? So I'm going to keep it here because Fy passes through B. So Fy cancels out. So Fy0, all I'm going to consider now is Fx. So rotate Fx about B. That is clockwise. Therefore, that's positive Fx. Then distance, just count how many blocks. 1, 2, 3, 4, 5, 6 times 6. And what's Fx? It's 160 times 0.3 times 6, which is what? Correct, Jade and Kathleen, 288. So Simon and Castillo. Positive 288 kilogram. Next, MC, summation of moment at C. Oh, by the way, before you continue, this negative sign means your moment about A is counterclockwise. This positive sign means your moment about B is clockwise, okay? So if you've noticed earlier, all our answers are positive. That is because you're equating a value to your equation. So a positive number means your assumption is correct. Okay, this is my assumption for direction, right? We got positive, so that's correct. If you get a negative answer for this type of solution, meaning that means your assumption is incorrect. The direction is incorrect, okay? So take note, if you're equating two equations, so here 120 equals to Fx, a positive number means assumption is correct. However, unlike what we're doing here, we're not really equating anything. We're looking for the value of something. The sign will dictate its direction, okay? So previously, you assumed a direction. Now, your answer dictates that direction. Okay. So in case some of you get confused, why am I getting a negative answer here? Earlier, I didn't. Okay, so continuing, letter C. So C, you can use this as well. Fx is this distance, Fy is this distance. Or again, you can make things easier. I'm going to put Fx and Fy here instead, because my Fx will pass through C. Okay? And then Fy. So Fx is passing through C. Not gonna ignore that now. Fy rotated about C. That's clockwise. So positive Fy times the distance 1, 2, 3, 4, 5. It's 5 blocks. And Fy is 120 and 0.3 times 5. That is, yes, 180. Correct, Andre and Ka. Sige. Pagbigyan natin yung iba. Si Samantha. De La Vega and Ical. Giselle? Janelle? I don't know. De La Vega. Giselle? Icale? I don't know. So once again, that's 180. And then last, D. Where's D? It's here. Now, if I extend this, yeah, I'm eventually gonna hit a position where my Fx will pass through D, but that's gonna be more tedious. The purpose of this is to make my equation shorter. So instead, I'm just gonna use, yeah, I'm gonna use either one. Okay. So let's choose this. So let's start with Fx. Fx rotated about D. That is clockwise. So positive Fx distance. And extend that. This is the perpendicular distance about D, which is 3 blocks. So 0.3 times 3. And then Fy, rotate it about D. That is counterclockwise, so negative Fy. Then distance from D, once again, extend that. This is the distance, it's just 1 block. So 0.3. Fx is 160. Fy is 120. Right, what's the final answer? Correct, Erwin? Ba't yung nakukuha ang 144? Mali. Tama ang 108. So it's Erwin and Villamor. Mark. Nabayo Villamor. Yeah, 108. Baka inad niyo. Yan, so that's F. Now do everything the same for P. Okay. Oops. I don't want that. Oh my gosh. Okay, let me just make this smaller. Para kasha yung P. Mm-hmm. Okay, P. Okay. So P, let's start with A. So we can solve. Okay. We can try solving for P. You can choose where to put your P. Let's say I'll put it here. For example, you did not extend the line of action of P. And as you can see, either position here in the drawing doesn't really make your component pass through A. Okay, for example lang. So let's put Px and Py here. This is your Px, this is your Py. Again, following the actual direction of your force. So let's start with Px. Px is counterclockwise, so negative. Negative Px times perpendicular distance, so it's this. So that's 1, 2, 3, 4, 5, 6 blocks. So 0.3 times 6. Next, Py. It's clockwise about point A. So positive Py. Then distance. So extending Py, it's 1, 2, 3, 4. 4 blocks. So what's the answer? Considering you should have stored Px and Py. I'm not gonna write the equation anymore. Oh wait, Px. 1, 2, 3, 4, 5. Yon, 0. Correct, Simon and Borde. Practice iba sa inyo. Equation. 0. Yes, it's 0 kilogram meter. Why? If you notice, if you try to actually extend this P, you're gonna realize P is actually gonna hit A. And remember, when your force passes through your point in question, moment is 0. So if you just did that, you can directly just say MA equals 0. Okay? Or if you didn't know that, you can go through this process. Okay, now let's move on to letter B. Moment at B. Okay, so I already put my components there. Px passes through B, so Px is not considered anymore. So let's use Py. Rotate py about b, that's counterclockwise. Negative py, distance is just 1 block, so that's just 0.3. What's the answer? Correct, Crystal and Mark. So, Lakian and William. Okay, it was 41.19 kilogram meter. Next, let's move on to C. So looking at C, I already say I should put my components here. Okay, so this is px, this is py. Okay, px passes through C, so I'm not going to consider that using py. Rotate it about C, it's counterclockwise. Yeah. So negative py times distance. Okay, so this is the distance from py, that's 1, 2, 3, 4 blocks. So 0.3 times 4, what's the answer? Correct, it's 164.75. Who got it first? Nicole, John, and Mark again. So Torres, Villamor, sino pang di nagka-points? Let's give it to De Leon. Mga di pa nagkaka-points. So Torres, Villamor, Garing, Simon, De Leon. Torres. And sino yung wala? De Leon. May ka na pa. Hindi wala pa. Yan. Okay, so this was negative 164.75. And then lastly, moment at D, where's D? I'm going to use this again because Px passes through D. So using Py, that is clockwise. So positive Py times distance. How many blocks is that? 1, 2, 3, 4. And what's the answer? Yeah, it's 164.75 as well. Oh. Okay. Positive 164.75. Bakit, Carla? Di ba kita nagbigyan ng point? Ano? Sige, sige, wait lang, wait lang. Yung mga wala pang points, wait lang. Your time will come. Sige, sige. Talaga. Oo. Kaya niyo yan, guys. Magkaka-chance din kayo. Ayan. So we're done. Any questions for this number? So that's basically it. That's how you get moment of each force. Okay. Half of it. You can just watch the recording. This is recorded. This is recorded, so no worries. Okay. So do you have any questions? Can I move on to the next problem? You have a lot. Oh, I'm sorry. Wala akong magagawa sa internet mo. Okay, gets pa. Let's move on to the next. This Keyboard is open notes and you can ask your classmates anyway. So that So let's move. Number 3. Got 30 more minutes. So, bilisan na natin. Since you got the gist of it. Number 3. Two forces, P and Q, pass through a point A, which is 4 meters to the right, and 3 meters above a moment center O. Force P is 8 Newton, 890 newtons directed up to the right at 30 with the horizontal, and force Q is 445 directed up to the left at 60 with the horizontal. Determine the moment of the resultant of these two forces with respect to O. So basically, the problem just illustrated your force. It states that this is 890 with that direction, this 445 with that direction, and we're looking for the moment of the resultant of that about point O n. Now you know how to get the resultant of forces, right? So if you draw the resultant, it's going to be something like this, somewhere here. Okay, getting the resultant. And if you can get the perpendicular distance of it from O, you can get the moment. Once again, I don't want to get the perpendicular distance, so I'm going to solve it a different way. Instead, I'm going to use the X and Y components. That's why you got PY and QY here and PX and QX here. Okay, so let's solve summation of moment about O. Let's start with P. So Px rotated about O, that's clockwise. So Px times distance, this is 3. Right? Next, Py rotated about O, that's counterclockwise. So negative Py times perpendicular distance, that is 1, 2, 3, 4. Next, Qx rotated about O, that's counterclockwise. Negative Qx. Perpendicular distance, that is 3. Also, yan, distances are shown. And then lastly, Qy, Qy rotated about, oh, that's once again counterclockwise, minus Qy multiplied by perpendicular distance 4. Okay, and then just sub in your Px and Py. Px, we're given your values, your angles. So Px is just P cosine angle. So P is 890 cosine 30 times 3 minus Py is just 890 sine 30 times 4. Then minus Qx, this is your Q. Qx is just cosine 60. So minus Q is 445 cosine 60 times distance 3. And then lastly, minus Qy. Qy is sine 60. So 445 sine 60 times distance 4. So what's the answer? Correct, Jade and Vivian. Ah, sorry. No, incorrect. Wala kayong nakitang drawing? Oh, no. Ito. So it's Jade and Erwin. Nabayos yun. Okay. So the answer was negative 1676.74. Yeah, correct, Vivian. And then the unit is, our unit is in Newton, then distance in meters, so Newton meter. Okay? Now, this negative means your moment is counterclockwise. So you can also write 1676.74 Newton meter counterclockwise. So for the following problems, I want to magsosolve. You can solve with me if you want so that you can just check your answer. Okay, let's move on to number 4. Without computing the magnitude of the resultant, compute where the resultant of the forces shown in the figure intersects the X and Y axis. So once again, to get the resultant, Resultant of these two would probably be something like this. It's an approximation. Something like that. Okay? That's your R. And then we're looking for we're looking for where it intersects the X and Y axis. So we're looking for this, let's call this intersection at Y. So IY, intersection at X. So to solve for this, again, use the concept that moment about a point is equal to the sum of the forces, or the moment of forces about that same point. We're looking for IY and IX. So most probably, IY, IX close to O, I'm gonna choose moment about O. Okay. So summation of moment about O, creating our equation is R D. D would be this. And I don't want to solve for that, so instead you're gonna use components. Okay? So if I move my component here, again, this being my RY, RX, as you can see, RY passes through O, so that's ignored. So summation of moment at O is now just Rx, right? Positive since clockwise, times this distance IY. In the same way, if I put my components here, then this RY, this is RX. RX passes through 0, so summation passes through O. So I can just say summation of moment is Ry and perpendicular distance Ix. Okay, so in short, I need to know this moment and I need to know Rx and Ry to solve for Ix and Iy using these equations. Okay? So once again, I want to solve for M moment at O and Rx and Ry. So let's start with Rx and Ry. So, kasha ba? Kasha. Rx. Let's start with Rx. Rx is just summation of forces X. So it's just the X component of these two. So there's no angle involved. We're given a matrix. So most likely this would be slope. So let's get the slope of this. Again, count the rise and run. So for this one, it's 3 base, it's 3 height. So this is 3, this is 3, this is square root of 18. Do the same thing here. And once again, as you can see, this is 3 base, 2 height, and then that is square root of 13. Okay, so 18, 13, right? Yep. So equals, let's start with the 500 one. So 500 times horizontal component, that's 3 over square root of 18. To the right, therefore positive. Next, 361 to the right, therefore positive as well. Times horizontal component, 3 over hypotenuse square root of 13. Solving for this, you get 653.92. Okay, so now you have Rx. Do the same for Ry. Summation of forces Y equals, starting at 500 again, upward, therefore positive. 500 multiplied by the vertical component, 3 over hypotenuse square root of 18. Next, 361 is downward, therefore negative 361 times vertical component, 2 over hypotenuse square root of 13. Once again, solving for this, you're going to get 153.31. I have Rx, Ry. Next goal is to solve for M, moment about O. Now, if you've noticed, right, 500, if I extended that line of action, you're going to see that it's going to hit O. Therefore, moment of this 500-pound force about O would be 0. So I'm not going to consider that anymore. So I'm just going to consider this. And once again, remember to get your moment about point, you can use components. I'm gonna put my component here. Okay. So let's call this P. Let's call this Q. So this now QX. This is QY. Okay. So moment of P about O is 0. Sulat ko na din. Moment of P about O is 0. That's why I'm not including it here. Next, QX passes through O, so again, don't include it. So QY rotated about O, that's clockwise. Therefore, positive QY, perpendicular distance 1, 2, 3, 4, 5 inches times 5. And QY is just 361 times QY, so that's 2 over square root of 13 times 5. So 361 times 2 times square root of 13 times 5, it's 1001.23. And I have all I need. Now I'll just write out the actual equation. Summation of moment about O is, using this, Rx times Iy. Okay, MO is this, Rx is this, so I can solve directly for Iy, which is 1.53 inches. Do the same thing here. Summation of moment about O now is Ry times Ix. Okay, since Rx passes through O, that's not included. MO is this, Ry is this, I can solve for Ix. So Ix is just 6.53 inches. And that is your answer. There. So that's number 4. Any questions for number 4 and number 3? Please answer in the chat if you have any questions. All right, great. Let's move on to the next. Last question for moment of a force. And into the figure the y coordinate of point A so that the 361-pound force will have a clockwise moment of 400 foot-pound about O. Also determine the X and Y intercepts of the line of action of the force. So we're looking for YA and then your X and Y intercepts. So I've already drawn that out. Okay, extending this is your Ix and Iy, your X and Y intercepts. So first of all, I want to know what YA is. So write out your given. We have a clockwise moment about O per 100 foot-pound, so positive. So summation of moment about O is positive 400 foot-pound. That's one of your given. Now I can use this. Or is it about O? About O. Yeah. I can use this to figure out Y. How? I can just take my components here, right? So that distance of this would include your YA. So this is your Fx, this is your Fy. Let me zoom in a little. Okay? Now, again, this is a grid, so this is gonna include slope. So count your slope. So this is 3, and it's not shown, but this is actually 2. Okay? So if you measure this, it turns out to be 2 blocks. So that's why that's 2. And then once again, this is square root of 13. Okay. Oh, Carlo, try to watch the recording since you're having net problems. So summation of moment at O here. Let's start with Fx. So Fx rotated about O. That is clockwise. So positive Fx Wait lang, let's rewrite it this way, and then summation of FB 400 equals, again, Fx times perpendicular distance, that's your YA. Next, Fy, that is counterclockwise, so negative Fy. Perpendicular distance of Fy, it's this, which is equal to 2 feet. So times 2. And then, rewrite your components. Fx is just 361 times 3 over square root of 13 minus 361 times Fy. So parallel to y is 2 over square root of 13 times 2. This is times YA pa. Okay, so using this equation, I can solve for YA. Solving for YA, you get 2.67 feet. Done. Next, solving for X and Y intercept. So like what we did earlier, to get your X and Y intercept, just place your forces here. Fy, Fx. Okay, so let's start here. Summation of moment about O is now just equal to Fx times Iy, because Fy passes through O. So summation of moment about O is given. Again, that's 400. Fx is just 361 times 3 over square root of 13 times Iy. So solving for Iy, that is just 1.33 feet. And then do the same for Ix. So summation of moment at O equals, using this, Fx passes through O, so ignore that. Fy is clockwise, so positive. Fy times distance Ix. So again, this is 400. Fy is just 361 times 2 over square root of 13 Ix. Solving for Ix, finally, you get 2 feet. So there. That's the answer to the last problem. Okay, we're done with number 5. Any questions with number 5? Okay, good. So that ends moment of a force. Yeah. Last topic for today is resultant of parallel forces. Oh, nawala yung ano ko. Header. Well, anyway, yeah, that's the next topic, resultant of parallel forces. So we're done with concurrent, now parallel. So the resultant of a parallel force system is determined when its magnitude, direction, and position is known. One of the outstanding differences between a concurrent and parallel force system is that in the former, position of the resultant is known by inspection, whereas the latter is not. So what does that mean? In our earlier examples, right, whenever we have a combination of forces, it's easy to determine our resultant is somewhere here. That's your R. For parallel force systems, you can't do that just by inspection. Inspection meaning looking at it. You have to solve for it. So to solve for it, and you can use this equation. So to determine R, select some convenient point O as a moment center. That is what we've been doing, selecting your moment center. Usually it's O. So summation of moment O is just RD. So resultant times perpendicular distance. So the concept of moment is still the same. Now, not usually you've been working with point loads, but you also have what we call your distributed load. So you have these common examples. So the resultant of a distributed load is equal to the area of the load diagram and is acting at the centroid of that area. These are your examples. Okay. And so area, and then it's acting at the center. This is a rectangle, right? Therefore, center is just length over 2. So your R is here. Length over 2, length over 2. And then its magnitude is just the area. Again, this is a rectangle, so area is just base times height, or height times base. So height is your WO, denoted as WO. Whatever value is here, for example, this is 5 kilonewton per meter. So that's just 5 times its length. So it's just W times its length. Okay. Next, triangular load. The center of a triangle is 1/3 its base. So that's why your resultant is here. And this is your 1/3. Okay, from the higher end. Therefore, that's 2/3 L. And then its magnitude is the area, which is 1/2 base times height. 1/2 height times base. So 1/2 height times base L. Okay? Now, if you have a combination of shapes, like here, you're just going to divide that into common shapes. So you actually can solve this as a trapezoid if you know where to find the center of a trapezoid, or you can just divide this into a rectangle and then into a triangle. So you have two forces. One is for your rectangle, so that's your F1, and one is for your triangle F2. So if you're gonna take the area, just take this part. Okay? And just to get the total force of this is just F1 plus F2. Okay. So that's parallel forces. Let's have a few examples. To determine the resultant of the parallel force system acting on the bar AB as shown in the figure. So resultant is just summation of forces, right? They're all in one direction, so that's easy to solve for. So it's all in y direction, so summation of force is y. Downward, downward, upward, downward, so negative 20 minus 10 plus 30 minus 40. Okay, easy as that. And if you take the sum, that's negative 40 pounds. That's the answer. Now, what if we're also asked to locate this? So to locate your R, again, in our concurrent force system, to find out where R is, you already know it's in between your forces. Here you have to solve. To solve for the location of your R, you're going to use moment. And then you're going to choose a point. So you can choose any point here along the bar. Let's say I want to choose A. So usually you want to choose a point where most of your forces are acting on so that you can cancel all of those forces out. Here at A, my 20-pound force is acting there, so that cancels out. Okay. And then MA is equal to R times D, where D is the distance of your resultant from A. Okay. So 20 passes through A, so that's 0. 10 is clockwise, therefore positive. Distance from A is 2. 30 is counterclockwise, therefore negative 30. Distance from A is 5. And then 40 is clockwise, so positive 40 times distance 3, 6, 7, 8 equals RD. R is downward, so you can just take a guess. Let's say this is your R. Okay, again, R downward. R rotate about A, that's counterclockwise. That's clockwise. Okay. So positive R, which is 40 times dA. And as you can see, I can easily solve for dA, which is 4.75 feet. And then to be specific, it's to the right of A because you got a positive answer. That means your assumption is correct. R is indeed to the right of A. There. That is number 1. Any questions with number 1? Okay, great. Let's solve a few more before your seat work. Let's have this. The beam AB in the figure supports a load which varies in an intensity of 220 Newton per meter to 890. So 220 to 890. Calculate the magnitude and position of the resultant load. So we're going to solve for magnitude and position, which is what we did earlier. So let's solve. So as I said earlier, the easier way to solve for this, or one way you could solve for this, is to divide it into parts. Okay, so one as a rectangle, the other as you can see, triangle. So center of this is here. Let's call that F1. Use another color for your triangle. Okay, and then its center is somewhere here. Let's call that F2. And distance from the higher end is L over 3. So 6 over 3, that's 2. And then obviously this distance is 3. Right? Okay, so resultant is just summation of forces. All of this is downward, so Y. So let's start with F1. So that's negative F1 minus F2. F1 is just the area. So area is length base times height. Height is this. So that's 220 times length 6. Negative. Then minus, this is the area of a triangle. So 1/2 base times height. 1/2 base is 6. Height is, this total height is 890. This is 220. So this height is 890 minus 220. Okay? And then if you solve for that, you're gonna get negative 3,330 Newton. And that negative, since we just solved for a value, that negative means it's downward. So, or 3,330 Newton downward. Or you can write the whole word downward. Okay. Next, position. So to get the position, you're going to choose an arbitrary point again. So you can choose it at A or at B. So I'm going to choose it at A. So summation of moment at A is RD. So you're going to guess again where your R is. R is downward, so let's say R is somewhere here. Okay. So this is my guess for R. So MA is the summation of forces. So let's start with F1. F1 is clockwise. So positive. Then its distance from A. F1 is the center of your rectangle. Base is 6. So therefore that half of that is 3. Next, F2. F2 is clockwise. So once again, plus F2. Distance from A. If this is 2, this would be distance 4. Then equals RD. So equals R is clockwise as well. So positive 3, 3, 3, 0 times distance. This is what we're looking for, A, dA. And then this is your F1. This is your F2. So solve for that. Use that here. You can solve for dA, which is just 3.60. Then unit, our unit is in meters. So meters, then to complete positive answer, therefore correct assumption, it is to the right of A. If you get a negative, that could mean your R is to the left of A. Yun. There. Any questions for this? What number is this? Number 2. Any questions for number 2? Okay, good. And last number for today. Yeah, but trust. So yung mga CE dyan, listen carefully. Or kidden, we're gonna design this, right? Locate the amount and position of the resultant of the loads acting on the think truss in the figure. We have that. So we're just looking for resultant and location, like what we did earlier. So it's just a repeat of the process. The resultant is easy. That's just summation of forces. All of it in Y, all of it downward. So negative 890 and minus 1335 minus 8900 minus 1780 minus 1335 minus 890. Solving for that, you get negative 15,130. Or once again, it could be 15,130 Newton downward. Okay. Once again, if you're just solving for a value, the sign will dictate the direction. If you're equating two things, two equations, positive means correct assumption. Okay, so first part done. Next, second part. Now, if you stare at your think truss, you can see that we'll encounter a problem. If I extend this force, its perpendicular distance from either side would be a certain distance, right? And it's not given. The only thing that's given is this. So first part is I need to solve for that. Okay. So let's put that there. And then this is x. Okay, so we're solving for x. So to solve for x, you're given this 30 degrees here. And then this is a think truss, meaning this is perpendicular to this. Okay. So I have 30, this is 3. If you consider this larger right triangle, I can solve for either this or this, right? But my goal is to solve for this. So the more logical value to solve for would be this side. So let's call that L. Okay. So once again, considering this larger right triangle, ilagay natin kulay. And so I'm looking for this. Given is this, which is the hypotenuse of my right triangle. So we're going to use cosine. So cosine 30 equals adjacent, which is your L, over hypotenuse 3. So I can just write L equals 3 cosine 30. And then to solve for x, just consider this smaller right triangle, right? And this is a smaller right triangle. So again, using this angle, I've solved for L, which is now the hypotenuse of my smaller right triangle. And then I'm looking for this, which is adjacent to that angle. So I'm going to use cosine again. So cosine 30 equals adjacent, which is now x, over hypotenuse L. So x is just L cosine 30, and L is just 3. So 3 cosine 30 times cosine 30. I think that's, the distance is 2.25. Yep, 2.25. Okay, so now I know that distance x, no problem there. Next is to actually solve for my position of r. So r is negative, so that's downward. Again, you're gonna guess where your r could be. My guess is it's somewhere here. Okay, so that's your R. And then use again the equation M equals RB. And then take an arbitrary point. So let's say A. By the way, if you want to practice, you can resolve everything and just take B as your moment now. Then you should have the same answer. So far, I've been using A. The summation of moment A is R, B from A. Okay, so isa-isahin natin. 890 passes through A, so that's not included. Next one, 335. They're all clockwise, since they're all at the same direction and position from A. So they're all positive. Positive 1, 3, 3, 5. Distance, X. Again, X is 2.25. Next, plus 1335. Sorry, plus 8,900. Distance 3. Next, plus 1780. Distance. This is half of 3. So this length is actually 1.5. So therefore, distance of 1780 from A is 4.5. Okay. Next, another 1335 there. Distance is so they're symmetrical, meaning this X is the same as this X. Okay. So therefore, if X is 2.25, this length is actually just 3 minus 2.25, which is 0.75. Okay. So therefore, total distance of 1335 is 3 plus 3 plus 0.75, that's 6.75. And then finally, 890 distance 9 equals RBA. Again, R is 15130. It's also clockwise, positive, and times DA. So I can solve for DA. DA is just 3.62. Unit is meters. Positive, therefore correct assumption, it's to the right of A. And that ends our lecture for today. Do you have any questions for number 3? Okay, since you don't have any more questions, you can now proceed to answer your seat work right now. If you go to week 2, you'll see this. So answer this, you have 3 attempts. Highest score will be your grade, and then upload your solution here. Deadline of this is today, 11:59 p.m. Okay, soft deadline, 11:59 p.m. today. And then next meeting, which is Tuesday, is your quiz number 1. Coverage is everything I've discussed so far. Okay. And by the way, if all of you manage to submit your seat work early, okay, I'm gonna upload the solution to your seat work early as well. Okay. So, however, if there's one person who hasn't answered their seat work yet, I'm not gonna upload the solution here. Okay. So everyone has to upload, everyone has to answer before I upload the solution if you want it. Okay. If not, I'm gonna upload the solution after a week. Okay. Do you have any questions before I dismiss you so that you can answer your seat work? Now, there's no timer. You have until 11:59 p.m. to solve for it. And open notes, you can ask your classmates for help. Just make sure you understand the solution, okay? That's the purpose of this seat work.
So ma'am, yung solution po is kailangan po lahat talagang magpasa ng solution po bago po mabigay yung answer key.
Yes.
Oh no.
Ganun na.
Thank you po ma'am.
Okay. Tatlong questions lang yan.
Tatlo lang po.
Oo, tatlong questions lang yan. So, try nyo, work together, sagutan nyo lahat para ma-upload agad yung solution para maaral nyo for your quiz.
Okay po. Thank you po ma'am.
Okay. Wala na? No more tanong? Wala more tanong? For the people who have questions with Coursera, I'm gonna upload something later in your groups. Excuse letter for diagnostic. I didn't receive any messages last night. So if you sent it today, hindi ko pa na-check. Yes, I upload the PowerPoint. The PowerPoint is here. Ayan, nandito. You can create your GC if you want. Go ahead, GC.
Hey ma'am, may tanong lang po ako about sa diagnostic.
Yes?
May retake po ba?
Yes, retake of diagnostic is until today, 11:59 p.m. as well, because we took it last week, Thursday as well.
Ay, okay po ma'am. Late enrollee po kasi ako.
Okay. So for those who are late enrollees and haven't had their diagnostic, send me an excuse letter today so that we can schedule your retake today as well.
Okay po. Through course message na lang po.
Yes, through course messages.
Salamat po.
You're welcome. Any other questions? Really, I didn't record it. Yes, it's 5%. Diagnostic exam is 5%. Last Tuesday? Really? I didn't, tingnan natin. Hindi ko lang, oh yun. Yep. Rosaline, I did not receive your excuse letter. Course message, through course message, okay? So please send it to me again, Rosaline. So Coursera, you can message Center of Teaching and Learning, CTL, if you haven't received your link yet. Any other questions before I dismiss you? Lana? Okay. So once again, Coursera problems, message CTL, Center of Teaching and Learning. I'm gonna upload, I think I've already uploaded your concern with Coursera in the groups. By the way, we have an FB group. If you're not there yet, please join. You have until 11:59 p.m. today to answer your seat work and upload solution. If everyone has uploaded the solution, I'm gonna upload the answer key. If you have not, if there's a single student who has not taken the seat work, I'm not gonna upload it yet. I'm gonna upload after a week instead. All right? Okay. Again, quiz next meeting. Please review. Open cam, open notes Zoom meeting. Okay. And since you don't have any more questions, good luck on your seat work. You may go. Goodbye, class.
Thank you, ma'am.
Thank you po,
Thank you po,
ma'am.
ma'am.
Thank you po, ma'am.
Thank you po,
Thank you
ma'am.
po, ma'am.
Thank you po ma'am.
Thank you po.